Hi, students. Welcome back. This is chapter 5 and the third part. We talk about polyatomic anions, how we name it, the chlorates, so iodates, always the phosphate. So the very common ions that ends with 8. And also we look how we add it into the acid. So like acid, like if there's nitrate, when it goes to the acid, like HNO3, it's going to be nitric acid. Sulfate is SO4 2 minus. When it goes to the acid, we call sulfuric acid. And I have a work example. The example here: determine the formula of sulfurous acid. So the sulfurous means OUS at the end means the acid. The anion is ends with ite. So SO4 is sulfate, so the anion should be SO3. So H2SO3 is the acid. And now I'm going to another type of nomenclature, which is the hydrates. The hydrates is the last part of the nomenclature. Basically, when we leave the ionic compounds in long time, we store them in the labs. These ionic compounds associate with water. So you name them like they associate with one water molecule, two water molecule. You basically, if you have the name something like this, copper two there's a problem. No, this is correct. Copper two sulfate, because this is two, copper also two, sulfate also two, so two cancel. But the mistake is this: the parenthesis should come after four. So copper two sulfate pentahydrate. Beryllium chloride, because beryllium is an cation that form only one type of cation, so barium chloride dihydrate. Lithium chloride monohydrate, magnesium sulfate heptahydrate, strontium nitrate. How do I know? No, forget about it. Strontium nitrate. It's not two, because strontium is always from one type of cation. Strontium nitrate tetrahydrate. So when they're leaving it for a long time, so the copper sulfate is white, but in anywhere you see it's blue because it always associates with water. So there's some very common names, like we don't say dihydrogen monoxide, we call water, ammonia, we call carbon dioxide, salt, laughing gas, limestone, baking soda, like that, okay? And then I'm coming to some calculation part, the very last part, the molecular mass or formula mass. If I ask you to calculate the formula mass of water, that is mass of a formula, you just add atomic mass of two hydrogen, but you have two atoms. See, that's what I use. You get the atomic mass unit from the periodic table, and then the 16 for the oxygen you add all together. And then although an ionic compound does not have the molecular mass, we can use its empirical formula to determine its formula mass or formula. So we always look at the ionic compound, get the empirical formula, and we get the mass of it. So I have this quick question. Calculate the molecular mass or the formula mass as appropriate for each of the following compounds. Propane C3H8. Get the mass of carbon, which is 12.01, multiply by 3, because you have three carbon atoms. Hydrogen 1.008 by 8, and you add all together. Lithium hydroxide, get the mass of lithium, 1 atom. Oxygen and hydrogen, you add all together. Beryllium, okay, this is good one. Barium carbonate, barium acetate. You don't want to worry about the name here, but it's barium acetate. So you add the mass of the barium, and then you add all together. 2 carbons, which is 12.01 into 2, 3 hydrogens, which is around 57, and then oxygen, 2 oxygens, and then you add all the mass together in the parentheses, and you multiply by 2, and then add to the mass of the barium. So then that's how you calculate the formula mass. And then sometimes I ask percent composition by mass. Let's do a question. That's easy. So for a molecule of water, I'm asking what is the hydrogen peroxide here? For hydrogen peroxide, what is the percent composition of hydrogen? So the mass of the whole compound is 34.02. Mass of hydrogen is 2 out of it. So you get the mass of hydrogen on the top, which is numerator, divide by the total mass into 100, 5.996. So that's how you do. Similarly, get the mass of percent composition of oxygen, get the mass of oxygen into 2, divide by hydrogen peroxide mass. So that's how you get the percent composition of compounds. Okay, so that is the percent composition, and then I have another question for you. My question is the empirical formula mass of hydrogen peroxide, which is HO, is 17.01 AMU. So percentage of hydrogen and percentage of oxygen, I get this. So you get the HO and then 5 point, because it's 1 to 1. Question. My question is, lithium carbonate was the first mood stabilizing drug approved by FDA for the treatment of mania and maniac depressive illness, also known as bipolar disorder. Lithium is not that safe element, but that's the drug they combine. Whenever it comes to the drug, they change the composition. You can easily think that, the sodium chloride. Sodium is toxic, and it's a metal, but chlorine also toxic gas. But it combined, it forms sodium chloride. It's totally different properties, like that. So calculate the percent composition of mass by mass in the lithium carbonate. So my compound is lithium carbonate. What is the very first thing? I have to find what is the percentage of lithium in the compound. What is the percentage of carbon in the compound? What is the percentage of oxygen in the compound? Very first, mass of a compound formula is the formula is the mass percent so the mass of an element, mass of a compound into 100. Oh, what happened? So now in order to find the mass of lithium carbonate, I need to get the formula mass. So lithium carbonate, lithium is 3 into 2 plus use the 12.01 into 1 because it's 1, and then the oxygen, you get the mass, it's 16 into 3. You may wonder why I use 16, just use the period. I would go with the in the round number, but you can always use the with some decimal places. It will give you more accurate number. So when you add all together, you get 73.89, and then get for the percentage of lithium. The compound has the compound has 2 lithium, so 6.9. For say that I took so the mass of the lithium is 2 into 6.941. Always is always good to double check because I took lithium 2, I think, right, in the previous one. So it's not 3, it's 6 because it's number of mass, protons and the neutrons. So 2 into 6.941 by 2 because I like lithium 2 atoms divided by the total mass of a compound. Mass of the carbon divided by the total mass into 100. Like that, you can find the mass percent of the compound. So molar mass is we already discussed molar mass, the mass of the 1 mole of a compound. So we already discussed this molar part, and then the mass to mole conversion, atoms. I have a separate video on this. Please watch that. And I think I'm going to do the calculation, so it's easy for you. But the theory part, please refresh. We did it in, I think, chapter 2. Okay. So my question, determine the number of moles of carbon dioxide in 10 grams of carbon dioxide. So number of moles, you take the given mass, which is 10. In order to convert to moles, you divide by molar mass for carbon dioxide. So in this particular case, we know carbon dioxide, so we have 10 grams, 10 grams, and then molar mass of CO2, carbon is 12.01 into oxygen is 16 into 2, you get the 32 by 12.01, 44, you divide, you know, 1 mole. You know it is, so you have given the 10 grams, please. 10 grams, 10 grams is 44 grams of carbon dioxide is 1 mole. So gram cancel. Basically 10 divided by 44. My next question. The mass of 0.905 moles of sodium chloride, you get the number of moles. In order to convert to mass, you multiply by molar mass. So 0.905 moles, moles, and then you take 1 mole multiplied by molar mass of sodium chloride, which is 58.44 grams. So then you have the answer. So I have another question. Determine the number of water molecules and the number of hydrogen and oxygen atoms in the 3.26 grams of water. So in order to find the water molecules, so you know I have my given mass is this. So I want to convert into so now we have to convert into molecules. So first you have to convert into moles. In order to convert to moles, this step, here you see, this step they convert moles of water, and then they multiply by Avogadro's number in order to convert molecules. When you talk about elements, remember we use the Avogadro's number to convert to number of atoms, same as here it's not atoms, they are molecules. So you take the Avogadro's number and you multiply it. And then determine the mass of 7.92 into 10 to the power 19 carbon dioxide molecules. So, oh no, we have to do the part 2 here. Let's go to the part 2. And then the number of atoms. So then they ask you number of hydrogen and oxygen atoms. So you know water. So if you take H2O, so the molecule has same number of, so one molecule has 1 oxygen atom, one molecule has 2 hydrogen atom. So when you get the number of molecules, you multiply by 1. So the same number of molecules as oxygen you have, but you have twice the number of hydrogen because it's H2O. And let me look at the next part. The next part is the mass of the carbon dioxide. So in order to, you have this many carbon dioxide molecules, so you divide by the Avogadro's number to get the number of moles. Once you get the number of moles, you multiply by the molar mass. So here in this step, this is the Avogadro's number. You divide by the Avogadro's number, and then you get the here number of moles. Once you get the number of moles, you multiply by the molar mass and get the mass of carbon dioxide. So I think that's the main thing in the chapter 5. I cover most of it. And I hope this video is helpful for you to better understanding the chapter. I'm always telling you it's not enough just to watch the video. You need to study by your own and make your own notes, do more practice problems, and then anytime if you have any question, you can always ask me. Thank you so much and good luck.